Welcome to this class. This session, we are going to derive numerical differentiation formula based on Newton backward difference interpolation formula. Numerical differentiation based on the Newton's backward difference formula. So consider the function y equals to f of x given at the tabular points x0, x1, x2, x3 up to xn, which are equally spaced. So then the Newton backward difference or interpolation formula is given by f of x equals to f naught plus so f naught plus, or can write it fn plus p backward fn plus p into p minus p plus 1 divided by 2 second fn plus p into p plus 1 p plus 3 p plus 2 power 3 factorial third backward of fn. So remember, fn means the value of the function at a general point xn plus p into p plus 1, p plus 2, p plus 3 over 4 factorial fourth backward of fn plus p plus 1, p plus 2, p plus 3, p plus 4 over 5 factorial fifth backward difference of fn plus other several terms and then plus p into p plus 1, p plus 2 to p plus n minus 1 over n factorial nth backward of Fn plus other terms. So let's call this one formula 1. So this is the Newton backward. So where you have always to say where x given by x naught plus ph. This is how x and p are related. So f prime of x is the same as df dx, but because this formula, the right hand side is purely in terms of p, and then with this relationship between p and x, then we can have use chain rule and say this is the same as df dp times dp dx. And from x equals to x naught plus ph, then dx equals to, this is a constant 0, so the h dp. So it means when you divide through by h, divide through by h, and divide through by dx, divide through by dx, then dp dx is given by 1 over h. So this can be written as df dp times 1 over h, which will just be the same as 1 over h df dp. So therefore, differentiating formula 1, we have f prime of x is equals to 1 over h d dp of fn plus p backward fn plus p into p plus 1 over 2 factorial second backward of fn plus p into p plus 1 p plus 2 over 3 factorial third backward of fn plus other several terms, i.e. f prime of x will be 1 over h. So that we carry out this differentiation with respect to p easily, let's expand this term. So we'll have d dp into, so the first one you just have fn plus p backward fn. Now when you open this bracket here, we'll have p squared plus p over 2 second backward of fn. Next one, when you open this one, you'll have p cubed plus 3p squared plus 2p over 6, 3 factorial 6, third backward of fn plus next term. When you write the next term, you'll have opening it p power 4 plus 6 p power 3 plus 11p squared plus 6p divided by 4 factorial is 24, fourth backward fn. And if you write the next sum with the fifth backward difference, opening it, you'll get p power 5 plus 10 p power 4 plus 35 p power 3 plus 50 p squared plus 24p divided by 120. Then you multiply by fifth backward of fn. Next one, if you write the term in the sixth backward difference, then the 6 factorial is 120, 720, and we'll have p power 6 plus 15 p power 5 plus 85 p power 4 plus 225 p power 3 plus 274 p power 2 plus 120p. Please write those terms and expand to confirm these sentences. And then plus other several terms. So let me call this one 3. So 3 becomes, now remember fn, these are just value of function at xn. So these are constant. So when you differentiate with respect to p, you get 0. So that means that our f prime of x will be 1 over h into, so this term, when you differentiate, you get 0. This one, because there's only p, so you get 1, and this you get backward fn. Here we get 2p plus 1, 2p plus 1 over 2 second backward of fn plus, when you differentiate this one, you get 3p squared plus 6p plus 2 divided by 6 third backward of fn plus, next term, when you differentiate this with respect to p, you will get 4p cubed plus 18p squared plus 22p plus 6 divided by 24, and then fourth backward of fn. Next time when you differentiate, you get 5p power 4 plus 40p power 3 plus 105p squared plus 100p plus 24 divided by 120, fifth backward of fn plus, next time when you differentiate, you get 6p power 5 plus 75p power 4 plus 340p power 3 plus 675p squared plus 548p. You divide by 720, then this is 6 backward fn plus other several terms. Call this one equation 4. So equation 4 is used to carry out first derivative with respect to Newton backward difference formula when you have an untabulated value. So formula 4 is used to find f prime of x for non-tabulated values of x. Non-tabulated here has the same interpretation as what we gave in the previous explanation when you are doing Newton forward formula. Non-tabulated values of x. So if we let or set x to be x naught, then from x equals to x naught plus ph, we have x naught equals to x naught plus ph, which means 0 equals to ph, which means p equals to 0. So replacing in 4 for p equals to 0. Now if we replace p equals to 0 in 4, we get that the derivative at x naught is given by, so this is what I'm saying. In this equation number 4, where there's p put 0. So when you put 0 here, 0 times 2 will be 0 plus 1 is 1. So this will be 1/2. So coefficient of second backward will be a half. Put 0 here, put 0 here. Then we'll have 2/6, which is a third. So coefficient of third backward of Fn is 1/3. And then put here 0, put here 0, put here 0. We'll have 6/24. 6/24 is 1/4. So we'll have 1/4 as the coefficient of this. When you put 0 here, put 0 here, put 0 here, and then here, we'll have 24/120, which is 1/5. And you put 0 here, you put 0 here, you put 0 here, you put 0 for p. Remember, there is no p here, so that should be 548. So then there's 548p, and then plus 120. We didn't. There's also a plus 120 here. If you write the term, the coefficient of 6 backward, you'll find that there's also 120 here. So try to open and confirm that. So put 0 here, then you'll have 120 divided by 720, which is 1/6. So there is a pattern. So you can even predict the next term. So we'll have backward Fn (1/h) into backward Fn plus a half, and then second backward of Fn plus 1/3, third backward of Fn plus 1/4, fourth backward of Fn plus 1/5, fifth backward of Fn plus 1/6, plus 1/7. That you can write as many terms as you like, because there's already a pattern. Plus other several terms. So call this one formula 5. So formula 5 is used for finding the values of the derivative for tabulated points. So formula 5 is used for computing values of f prime of x as tabulated point. Points of values. So that means that you'll be asked to find the derivative for a value of x which is already given in the table that you are given to use. So in the next session, we'll also derive the formula for second order derivative using the Newton backward interpolation formula. And then thereafter, we'll now be doing examples on how to apply these numerical formulas. Thank you.